And and some things have changed in the world. Let me catch you up on some things that have changed, at least in relation to this course, and maybe also uh, with me. Um, okay, one of the things that's changed is right now, um, the United States here, we are now, this time of year, we're 11 time zones behind Kyrgyzstan. Okay, now how does that work? Changing the time zone, because previously in the lectures, we were only 10 time zones behind. What happens is twice a year, uh, the uh, the government changes the official time for the United States by 1 hour, and um, it's not completely understood if the idea behind this works or not. And here's the idea: is that in summer, when the days get longer, uh, it might normally get dark here in Florida, let's say in the evening at 8:30 p.m. And what they've done is they change across the state, and each state can do it. We have 50 states, so each state can choose to do this or not. And the state moves the clock ahead so that when the sun sets, it's not actually 8:30, but it's 9:30. Of course, that means that the sun also rises in the morning an hour later, okay? Because we can't actually add an hour to the day, okay? So, and they do this with the idea of making it appear to people um, that the day is even longer than it actually is. So when the sun sets at 9:30 instead of 8:30, people have an extra hour of daylight to go about their business. That's the idea behind it. Whether that actually works is unclear because it also happens in the morning at the other end. The sun doesn't rise until an hour later. So the idea is psychologically, people will still get up at the same time, whether the sun is has risen or not. But when they get to the end of the day, and it appears that we have an hour extra of daylight. So that's the idea behind it. It's not clear how well that actually works, but that's what happens. So once a year, the clock, the time on the clock is moved forward, make it appear we get an extra hour of daylight. And then at a different time in the year, the sun is moved backward to the normal time according to Greenwich Mean Time. And interestingly, the amount of the year in which we're on normal time is smaller than the amount of year in which we're on daylight savings time. So when the clock is artificially moved forward, it's called daylight savings time. And then it's moved back to normal Greenwich time. And so that's the idea behind it. Does it work? I don't know. I guess I'd kind of prefer that the clock stays set at the same time all year long. But that's not what the state of Florida does. For many years, I actually did live in a state which never changed their clock. That was in Indiana when I was a professor at Purdue. And and that made it odd because the rest of the country pretty much all moved their clocks forward and back. So when Indiana didn't move their clock, it made the time in Indiana different in relation to the neighboring states. When the other states moved their clock, the time in Indiana didn't change. So part of the year, Indiana was at the same time as the neighboring states, and part of the year it wasn't, which always caused problems, especially potentially in doing things like airplane flights. Okay, so there's that. So now this time of year, we are now where I'm sitting here in Florida, we're now 11 hours behind. So with that, the class for me starts at 6 o'clock in the morning, 6 a.m., whereas previous it was 7 a.m. Okay, so that's the difference. It's not really a big difference. So the other thing is today in the United States is election day. And so, because by the way, though our election process is set up now, election day isn't the day when everyone goes out to vote, because for weeks prior to election day, people can vote by mail, and there are what are called early voting sites set up. So people can go to these early voting sites and vote, or they can vote by mail. And election day actually represents the end of the election cycle. So already now, today, it's early in the morning here. Today is election day. In years past, this would have been the day when everybody goes out to vote. But this is actually the last day of the election cycle now. Almost 100 million people in the United States have already voted up until now. And so the remaining people who haven't voted yet are going out to vote. So the general wisdom seems to be that in this election, that most of the Donald Trump haters have voted early, either by mail or by early voting, whereas the Donald Trump supporters have waited to election day to vote. We'll see how that turns out when we look at the election terms this evening. And it is probably the most important election in my lifetime, only because Donald Trump is so controversial as president, and does things in such a different way than any presidents did before. So that is creating a huge amount of public interest here in the United States. And so we'll see how that all works out today. So I'll probably be up later this evening looking at the election results on television to see what's going on with that. Interesting, by the way, is I and everyone in my family here, we voted by mail, and I sent in my votes weeks ago, and we all did. And the three of us, or four of us living in the house here right now, two of my children and myself and my wife. And the three of us are all registered to vote, and we've all voted early. And all four of us have, and three of us are registered as members of the Democratic Party, and Mara, my daughter, is registered as an independent. So, and what happened is the three of us who sent in our mail-in ballots, because we're registered Democrats, and the three of us who are Democrats who sent in our mail-in ballots, what they do is when they get the envelope with your ballot in it, and you sign the outside of the envelope, and they compare your signature with a signature they have on file. And if the signatures match, they then accept the ballot and record the vote. But if they think the signatures don't match, they don't record the vote, and they send out a letter, and you get a letter saying your vote wasn't recorded because of a signature mismatch. Well, I got one of those letters, and my son got one of those letters. Um, and so then I can fix it. How do I fix it? Well, I download a form and I fill it out. An affidavit is what they call the form. I fill it out and sign it, saying that indeed I sent in my mail-in ballot. I sign it, and then I send in a picture of my driver's license, which also has my signature on it. So I um, send in a PDF of the form and a JPEG of my photo, and they got it, and they claim that I didn't send in my copy of my driver's license, which I did as a JPEG. So I figured maybe somehow when they opened the email, they couldn't open the JPEG, right? Who knows? So I then took my JPEG of my driver's license and I converted it to a PDF. And then I just resubmitted everything. I resubmitted the form, the PDF of the form, and now a PDF of the photo of my driver's license. And they accepted it. Exactly the same thing happened with my son. And I don't know if our signatures had changed so much or if perhaps, possibly, they confused it because we both have the same name, Neil Gallagher. And they may have looked at my son's signature online and compared it with my signature on the envelope. And they may have looked at my signature online and compared it with my son's signature by mistake. May have done that. But of the 2 out of the 3 of us who are registered Democrats, they initially didn't record our votes because they said the signatures didn't match. So a suspicious person might think, oh, there's a conspiracy there. They're trying to suppress my vote because I'm a Democrat. Um, my wife didn't have her signature rejected. And so, and we each, my son and I each had to submit our forms affirming our vote twice. Because the first time they said they didn't get the information because they couldn't read the PDF of the photograph. I mean, the JPEG of the photograph. So who knows, what's going on. Like I said, a suspicious person would think, oh, conspiracy. I tend to think, having worked with people in government over the years, I don't think there's a deep conspiracy in government. I think they're just incompetent. And so those a couple interesting little stories here. Now, in class here, what we are doing is we're going to be switching gears and moving out of Excel and moving into processing. And I got just about everybody, except for maybe 1 or 2 people, and there are maybe 30 people actually registered for this course. But just about everybody sent in their Excel project. I graded every project. No one got less than a B who turned in a project. And some people did some really creative things. And one person I found looked at countries that had women leaders compared to countries who had men leaders and looked at the success of the response to COVID. And the interesting result, I found it interesting and not surprising, was that the countries led by women did far better than the countries led by men. Why is that surprising, right? I'm a man. I know men are bozos, so it's not surprising at all. I mean, you have countries like New Zealand, um, which has driven their COVID rate down near zero. So that they're at a notification of another meeting, which of course I'm not attending. Okay, now So we're moving into processing now, and so let me share my screen now and start talking about processing here. Let me put my glasses back on so I can see what I'm doing. Open share tray, screen one. Okay, so here now, if you haven't done it yet, you need to install the processing development environment on your computer. And I've checked with IT people, and they assure me that you can download this. So what do you do if you haven't done it? You go to processing.org. That's what this is, processing.org. I don't know if you can read that. It's the website, processing.org. When you do that, you see this page pops up here. And then you go to download, and this comes up. So you have a choice of downloading processing to run on different operating systems. And I have my Mac download here. There's Linux right here. You download that if you have a Linux operating system on your laptop. Linux is a version of Unix. Actually, interestingly, Mac OS is also a version of Unix, but they're not completely compatible. Windows, you have Windows 64-bit, Windows 32-bit, download Windows 64-bit. Okay, so you download this and double click and install on your laptop. If you're having problems with that, you'd connect you with IT, and they should be able to help you. They assured me that you can download it and that it shouldn't be a problem, but it's never problem free. Okay, so when you download it, let's look at the rest of the links here on the processing website. Okay, you can forget about the donate link. They're looking for people to donate money so that they can continue to work on processing. Okay, so we have these things here, reference, libraries, tools, environment. These are all things to sort of help you with processing. And the reference here, click on that, and what you get is links to all of the different commands in the processing language. Now, processing is a regular computing language. So if you're majoring in computer science and you are doing processing, you will recognize it as a computer language like Java or like C or like Python or whatever. Processing is a regular computer language, but it's been designed for people who are not computer scientists to use the language to do multimedia and do graphics. So these are all the commands. Now we're only going to do some subset of these commands for the next few weeks, and what you find all these commands, and then if you click on them, it tells you about that particular command. So there's a function called rect for drawing rectangles. And then it tells you exactly how that function works when you use it. So if you have a question about a function and how it works, go here to this reference. You may need to use that from time to time. Now, we also have libraries, and I don't think we're going to need to download any libraries for the next few weeks. And libraries that I have used from time to time include the sound library in particular. Tools, environment, these are all things which help you use processing. So this tells you how the IDE Works. That's the development environment for processing that we're going to be using to write processing software. Down here are some things that are pretty important. There's tutorials, and we have tutorials by this guy. And I say in one of my videos, the guy's kind of manic, really, really energetic, outgoing, and he's a pretty good teacher, I have to say. I think he's better than me. You probably learn more looking at his tutorial videos than you do looking at mine. So then there are examples of using processing to do various things. And for example, and some of these can be pretty complicated programs. Let's say we just click on one. Oh, blur. If you're trying to blur a picture, here's a processing program that blurs a picture here, for example. So you click on here and you can actually find fully functional processing programs. You can also find fully functional processing programs online by doing Google searches. So there's a processing forum. Let me come down here. So you can go on here and post questions. Maybe people will answer them, maybe not. Processing isn't as bad as many online forums. Many online forums, you go on, you post a question, and the first 5 responses will tell you what an idiot you are. Either it's a stupid question, or it's the wrong forum for answering the question, or something like that. I don't know what it is that turns people into jerks online, but I don't know if these forums are like that. I hope they're not so bad, but you never know. But if you ask the question, like I said, the first 5 responses tell you what an idiot you are, but gradually you'll get responses that are actually useful. There's GitHub, which I've only used a few times. I don't consider myself a version on GitHub, is where people post their programs. When you go on GitHub, you can actually download programs that other people have written. And this is true with just about any. You can find C programs, Java programs, whatever on GitHub. And so there are these items which link you to various things that are about processing. Like here are issues. These might be things that don't work right in processing. Tabs not displayed inside text when using this and this. So things that don't work quite right or issues. Wiki, frequently asked questions, and so on. So that's what these items over here are. Now, let's go here. Tutorials, examples of processing programs, width and height. I might talk about that today. So examples of processing programs. And books. I'm using one of these books, which I have posted on the Moodle, or with a new version of Moodle, whatever they call it now. And I believe I have emailed this book out to everyone. And during the course of the next few weeks, I'm actually going to be going through this book, basically page by page, working out the examples in the book. I think this is a pretty good book as far as teaching a computer program. It's called Getting Started with Processing. So there's a few other books on processing. This is the one I'm using. This is the other one that they access you to online, not using this one, only using this one down here. Okay, now tutorials. Let me just look at this for a minute and pull this up so you can see. There's this fellow, like I said, he's a little bit manic, but he's a pretty good teacher, actually. So let's look at Hello Processing. I click on this. Click here to begin. Now you have these items down here: captions, restart, back 10 seconds. That's moving back in the video by 10 seconds. Jump to lesson. Let's do this. So,
all right, we're ready to get started. This is a very exciting moment because we're actually going to look at writing lines of code and drawing stuff to the screen. So what does it mean to write a line of code, right? A line of code is an instruction. What is the instruction we're going to start with? The instruction we're going to start with is draw a rectangle. So let's see, what is a rectangle? I think we all know what a rectangle is, hopefully. A rectangle
okay, so you can see this guy is, like I said, he's a bit manic.
What does it mean then to have an instruction which says draw a rectangle? Well, instruction is text, and an instruction is going to look like this. RECT. A function is essentially that command, that instruction. It's the word we use, and the function of rect is to draw a rectangle.
Okay, so you can go on there and look at his tutorial videos. And I said, like I said, they're pretty good. Okay, now with all of that, let me go back. Let me look at my syllabus here for the course. So we're entering the processing part of the course right here. Introduction to Processing, Chapter 2 in the textbook. The first sketch: draw rectangles and ellipses, make circles, set workspace, draw points, lines, and simple shapes. And for this week, I have 4 videos posted online. So look through these. There's also homework assigned for this week, just as I did before. You go toward the end of the syllabus and you'll find the homeworks. Now, with that, let me pull up processing. Here I started writing a processing program here. Let's and let me just sort of go through this. Here's one I started writing, but let me open a new one, and I'll just use this one as a guide here. These are some things that I haven't really talked so much about in these videos, and so I talk about something that's not completely identical to the video. So I'm in processing, file, new, open up a new window there. Okay. Okay, now I'm assuming that you know very little about writing computer programs in any language. And I look at processing as sort of being a variation on the computer language Java. But like I said, it's designed for people who are doing multimedia. And if you look at my videos, I have some examples of some interesting programs that I've been involved in writing over the years. One is a computer game written in processing, and the other is a multimedia presentation written in processing. And these are not meant to be super sophisticated examples. They're kind of relatively simple and straightforward. And like anything else, you would have to study this for a while and go over the entire textbook. And when I learned processing, that's what I did. I mean, I took no course on processing. I just downloaded the textbook and I went through that textbook page by page and did all the examples, which is kind of what I'm going to be doing here in class. Okay, so how do you write programs in processing? Okay, the first thing I'm going to show you is a comment statement. And whenever we write software, we really should put in a lot of comment statements. Because when we're writing the software, we may know what we're trying to do and how we're trying to do it. But in a few weeks or months, if we have to go back to that piece of software, we will have forgotten most of what we were trying to do. And we would have to spend a lot of time trying to re-understand what we originally did. If you write comments, it helps you in that process. So you write a comment in processing. There are 2 ways to write comments. The first way is you put a double slash like that, and then whatever you write. So there, whatever you write. Now, a comment statement is a statement that is not run by the computer. It's just the way that you add a note to the program. Okay, now, if I wanted to run a program, if I write the program in this window and I want to run it, I click on this link right here. See, it says run. When I click on it, I run the program. The only thing that happens when I run the program is this small little window opens up right here. This small window would be where graphics would appear if we were trying to do graphics. And we can make this window bigger. Okay, this is way too small to do anything significant. And how do I change the size of that window? Well, let me show you that. So I have a comment here. This program will be on some basic items. You can write a comment, some basic items. So you can put that here. And I say size. Okay, now, so size changes the size of that window. We can make it 500 pixels across and 400 pixels vertically. So I put 500 comma 400 and then a close paren. And at the end of every processing command statement, every time we're telling processing to do something, we end the statement with a semicolon. If you don't put in a semicolon, you get an error. So this changes the size of the window. So let me run this, and you can see there I get a much bigger window. It's 500 pixels across. Now, when you first do graphics in math in school, you might set your 0 point down here, and going in the positive X direction is going to the right, and going in the positive Y direction is going up. In our processing window, it's a little bit different. Our origin is set right here at this corner by default. We could change that if we wanted. Here's our origin. Going in the positive X direction is going to the right, but oddly, going in the positive Y direction is going down. So remember, as we increase Y, we're going down in the window and not up. Okay, that'll probably cause a few mistakes as we go along in this course. Okay, now something I'm not going to spend a lot of time with in the beginning here, but if we want to use variables in processing, so, like in algebra or calculus, you say, okay, let's take a variable X. And variables can be one of several types. And when doing arithmetic operations, your variables can be set either to integer valued or to floating point values. So integers are only integers, right? 1, 0, -1, -5. So they're whole numbers, either positive, negative, or 0. And so those are integers. Floating point numbers can be fractions. 3.245 is a floating point number. And so we have to tell processing if we're going to be doing integers or floating point numbers. Now, there are other kinds of variables, but I won't tell you about them right now at the moment. So, example here. Let's say I'm going to use integers. So I'll do, and the way I tell processing that a variable is an integer is I write int. And notice this is a statement recognized by the compiler and processing, int. So it's an officially accepted statement in processing syntax is int. It turns, they're a sort of a reddish orange. I say int x equals 1, semicolon. Now notice here, my x equals 1, there's no spaces. Here I put spaces. The spaces make no difference. And I have to end the line with a semicolon. Now I'm not really doing anything right now yet. I just set up the window and define a variable to be an integer variable. So there, the window's set up, and I'm not doing anything with x. But if I wanted to, I could print out the value of x. So let's do that. So this will be something that we're actually doing. What I'm going to do is I'm going to use a statement called print. Big surprise there. Now, if I want to actually print out text, I put it in quotation marks. So I'm going to print out the text that I'm going to say the variable x equals, and then I put another space, and then I put, oh, didn't want to do that. And then I put another quotation there, x equals, I don't want x equals x, this x equals there. Now I want to print x equals, and then I want to print out the value of x. So I put comma, and then I just write the variable x here, like that. And now I close my quotation. So I mean my parentheses. So everything in this parentheses gets printed. Let me run it and you'll see what I mean. So I run the, oh, I forgot a semicolon. If I don't have a semicolon, I get an error. Notice down here, processing is telling me I'm missing a semicolon. Now what happens if I run it without putting in the semicolon? I get an error, unexpected token null. So what they're saying is, was expecting to see semicolon, didn't see it, just saw a blank space. So I have to put in a semicolon there. Also tells me the line here that the error is at. Now, more often than not, when we make an error, and this tells us we have an error and what the error is, this will be meaningless to us. Okay, this is something, that tells the experts, the people who wrote the language, what's wrong. This doesn't tell you as a user much of anything, unfortunately. So we put a semicolon in here. So now we have a semicolon. Notice this statement here disappeared. So this was useful. So now what happens if I type run? I have x equals, and then the value of x, which is 1. And it opens up the window too, but nothing is going in the window yet. Okay, so prints what's in this print statement. If I change the value of x to 2 and run it again, I have x equals 2. So there, it's printing out the value of x. So whatever I type in here, I could type anything in here, junk. I don't have COVID, but it might just be too early in the morning for me. Okay, so let me print this. So it prints out junk. So whatever is between the quotation marks, it prints out those characters. Okay, so that's what it's doing there. Okay, so how we define an integer variable, and then how we print. Simple examples there. Okay, now I have other variables defined here. You see here, I define each variable separately on a new line, which is usually the way I do it. But now I don't have to say integer x equals 2. I could just say integer x here, like that. And now x has not been defined. What happens if I try to print that, run that? I get an error. Local variable x may not have been initialized. So I didn't define the value of x, but I tried to print it out anyway. So I'm getting an error. So here I declared x to be an integer, but I didn't define it. I could define it in another statement. Say x equals 1, and then put a semicolon. So here I declare it to be an integer, and here I define it to be equal to 1. So let's see what happens there. And it now prints out junk 1. Okay, so I could declare the variable to be an integer and set the value of the variable in separate lines. Now, what I started to say a few minutes ago was I can declare multiple variables to be an integer in the same line. For example, I can say integer x, y, and z there. So declaring all of these variables to be integers, but I've only defined x. Fortunately, when I run, I don't get an error because I'm not using y and z to do anything. Now, let me set y equal to 2. Y equal 2. There. So notice there's a difference between here and here. Here, I define the variable value and set it to be an integer in one statement. Same thing with y. Z, I didn't give it a value. I said z is equal to x divided by y. So x divided by y is 1/2. But actually, because this is integer arithmetic and not floating point arithmetic, it won't give me the answer 1/2. What does it give me? Ah, okay. So if you're not used to writing computer software, this could be confusing. And we're actually not going to be using these properties of variables a lot in the remaining weeks, but they're important properties, so I thought I would mention them. If in fact you're a computer scientist, this is one of the first things you learn, and you kind of have to know this. So watch what I'm going to do here. I have x and y defined. I'm going to set z equal to x divided by y, semicolon. Okay, and now I'll print z. There. So junk z, what I'm going to print. We know that if x is 1 and y is 2, x divided by y is 1/2. But what do I get when I print z? I get my open window, and I get 0. I don't get 1/2, I get 0. Why am I getting 0? And it's because x and y and z are all defined to be integers, and I'm doing in the computer what's called integer arithmetic. Now, whenever we're using integers and we're doing integer arithmetic, any fractions, anything that would appear after the decimal point is just dropped off. So we said z under normal arithmetic, z would be 1/2. 1/2 is 0.5. The 0.5 appears after the decimal point. So all that 0.5 just disappears. It's set to 0. So because these are all integers, I'm doing what's integer arithmetic. And z is set to be 0.5. But in integer arithmetic, everything after the decimal point is set to be 0. So the value I get for z isn't 0.5, it's 0. So that's what happens here. I get junk 0, junk's the text I'm printing. I get the value of z in integer arithmetic, which is 0. Now, if I set x equals 2, what do I get? So 2 divided by 2 is 1. 1 is an integer. So let's see what happens there. I print and I get junk 1. So I'm getting the integer value of 1. And what happens if I put 3 in? 3/2 is 1/2. It drops off the 0.5 after the decimal point. So using these rules of integer arithmetic, I should get 1. What do I get? 1. So even though 3 divided by 2 is 1/2, drops off the 0.5, and I get 1. Now if I put 10, 10 divided by 2 is 5, which is an integer. I get 10 divided by 2, which is 5. Okay, so this is the first potentially confusing lesson here in that what is integer arithmetic? Now, if we want to do normal arithmetic, we have to set x and y to be floating variables. So I would, instead of saying integer, I would do float like that, float x, y, z. Now, let me set y equal to x equal to 2, y equal to 3. So I have 2 divided by 3, which is 1.5. But I set these equal to floating, which means they can have fractional parts. That is, parts after the decimal. So 1.5 should be 1.5 when I print z. What do I get there? Oh, I'm sorry, I said 1.5, but of course that's not right, right? 2/3 is 0.66666, and the 6 is gone forever. And then if you round at some point, you get 7. So that's what's happening there. Okay, so so floating point gives us normal numbers with integer parts and fractional parts. Integer, we just do integer arithmetic. And sometimes we can actually use these strange properties of integer arithmetic to do things very quickly and simply. And virtually every computer program of which I am aware will do integer arithmetic. So this is, in fact, a useful property of programming is integer arithmetic, integer variable, floating point arithmetic. And so now let me just do one more thing, because most of what we're going to be doing in processing is graphics. And so I'm going to draw a rectangle. And how I draw a rectangle, type in the word rectangle. Let me put 4 numbers in, and I'll tell you what the numbers mean in a minute. And I do this in one of my videos, but I go through and I misinterpret things in the beginning on the video. So as I want to talk a little bit about doing experiments when you're writing programs. If you don't quite know how things work, you can do experiments to try to figure it out. Okay, rectangle. Okay, now let me just run this. Okay, so here's our graphics window, and you can see it's actually plotting a rectangle. The width of the rectangle is 250. So I'm sorry, I already made a mistake. The width of the rectangle is 150. That's this number. The height of the rectangle is going down is 100. The coordinates of this point right here is x equals 250, y equals 200. So x equals 250, and then y equals 200 brings me down. So that's what that point is. Then starting at this point, we do the width of the rectangle is 150, and the height of the rectangle is 100. So that's that. Let me do a different rectangle. Now, I can just copy this. I do copy and paste. I do the same rectangle. If I run this, it just plots this rectangle on top of that. And what you get here won't look any different. Watch. Looks the same. Now let me change this to 100. So it should, I don't want to do 1,100. So the upper corner on this second rectangle should be at x equals 100, y equals 200. It goes over 100, down 200. So it'll be down here somewhere, right? Where, or maybe here will be where the upper will be the upper left-hand corner. Then it has the same width and height. Let's run this. So there we go. First rectangle, second rectangle. Now, let me just make this 100, 100. So it goes to the left 100, down 100, and then I print, I run, sorry, I get this. So that's a quick introduction there to the idea of doing integer arithmetic, the idea of graphing rectangles. I look at my videos. I have 4 videos. Look at my videos. And then you can, like I said, if you want to look at the video tutorials by that processing guy. Like I said, he does a really good job. And I give a couple of examples online. Let me just quick show you now. A few minutes here. I got to find it. Let me do Bounce. Bounce is a computer game made in processing quite some time ago. Here's the program. Let me run it. Here's Bounce. And this is a program that does a game like the computer game Pong, which as far as I know was the first ever computer game ever made. And this was before there were laptop computers, actually. Pong was. And you could actually buy a console and hook it up to your television. And the only thing the console did was to run Pong on your television, and you could play it on television. So here is a version of Pong I wrote, I don't know, about 5 years ago, I guess, maybe a little bit longer, with a student, and to illustrate, interesting things you could do in processing. And I run this counting down to the start of the program. There. So you see there's a ball that bounces, and then you're supposed to hit the ball with your paddle. And if you don't hit it with the paddle, the program stops and your opponent scores a point. The computer is the red paddle, and you as the human are the blue paddle. So let's see if I can get it to work. There. Okay, so you can see how that works. I'll let it go. Okay, so yeah, it's a simple computer game. And so I talk a little bit about what were some of the issues in setting this up. The computer calculates the position of the red paddle. And you would think, well, the computer is always going to get the right position, so how are you ever going to beat the computer? So in order to deal with that, I introduce a random number into the computations that the computer did so that from time to time it would actually make an error. And in calculating the position of the paddle, actually had to use geometry. And then I look at the ball moving. Ball comes in and bounces and comes down. So we have these triangles of the ball trajectory. And so I had to use geometry and how fast the ball was moving to calculate the position of the paddle, and threw in a random number so that occasionally the computer makes a mistake. And then as you go along in the game, the speed of the ball will slowly gets faster and faster and faster, meaning that you have to be better and better on setting the position of the blue paddle. So there are a lot of unanticipated things in doing even this simple computer game. So, and all of these issues were involved in writing the game. And here is the processing code for doing that game right here. no audio snippet. So we have to play sounds whenever the ball bounces. It plays a drum struck, two different sounds for the drum. So it plays sounds. These are all these variables, float x, float x. So it defines initial values for the variables as floating point numbers. And then, so actually we're going to learn most of what these things mean in the process of the next few weeks. So I taught processing to high school and middle school students several years ago, and I did it because assuming most people who do computer programs actually aren't interested in being computer scientists. They're interested in doing something with the computer, such as making a game. So that's what this was about. So so that's a game, and there's another example that I give here. I think a bomb. Here we go. And this was, I did this with Mara, my daughter. And she was doing a debate for her class. And the class was divided into two groups. The debate was about the morality of the United States dropping the atomic bomb on Japan at the end of World War II. And and she had, like a lot of people, would get extreme anxiety about speaking in front of groups of people. She used to get it worse than most people. She would actually have a panic attack. She would hyperventilate, and it was pretty scary actually to watch her have a panic attack. So I told her she should do her opening comments for her debate team, which was what her job was, as a processing program. Let me just show you how that works. So here it is. Bomb is the name of the program, Bomb 25, Mara, Bomb 25. This explains the program right here. These are all comment. It's a different way of doing a comment statement where you do slash and asterisk, and then down here, asterisk and slash. Everything in between is a comment. So here it is. So this was her entire opening statement for her debate team. And it was all done in processing. Again, I don't view this as being a excellent example of how to do multimedia in processing. After all, it was done by a middle school student with help from someone who had never used processing before, me. And so let's see what this looks like.
The world will note that the first atomic bomb was dropped on Hiroshima, a military base. We won the race of discovery against the Germans. We have used it in order to shorten the agony of war, in order to save the lives of thousands and thousands of young Americans. We shall continue to use it until we completely destroy Japan's power to make war.
Okay, that's a radio address by the President Harry Truman, whose picture you're seeing right there. Okay, now you see in a moment, there'll be an animation that Mark created. Okay. Um, you can get an idea what the World War II was like there. I'm sure you know because the Russians were the primary army that defeated the Germans in Europe. And what Russia went through and the Russians went through was unbelievably horrible. And I don't know if I've mentioned this to any of you or not, but I I was in the army during the Vietnam War, and uh, it wasn't nearly as bad as World War II, but it was also quite horrible. Some of you, in fact, might have some personal experience with war right now because it's an unfortunate characteristic of humanity, it seems, that we are usually fighting wars in some way, somewhere. Um, now, with that, it's my introduction to processing. This is more traditional computer science as compared to Excel, which you probably would find more useful. And so that's all I have to say today. Let me now, there we go. Okay, hello there, everybody. And not as many people as usual are in class today. Maybe some people forgot. A couple of you sent me some emails with some questions, and I'll look at your email and try to send you a response to those questions. It's not, except for the early morning hour for me, I'm enjoying being back online here and talking with you all. And I hope things have been going well for you over the last few weeks. And so I don't have anything more to say. I will see if anyone has any questions. While I'm waiting for people to come on, see if they have questions. After I close out here, I'll take the video and I'll post it on YouTube as usual. But there are already videos that you can access from the syllabus, as you see. So this is more traditional computer science. So I hope you find it interesting and not too challenging. Most of you are pretty sharp, and I'm really quite happy with the, the the things that you did in Excel and the projects that you did with Excel. So we're moving forward here. Okay, if there are no questions, then let me stop recording and I'll see you in a couple days.